Amy Suggs again for the last, I guess, installment of section 1.2. This is the last piece that we have to put together the puzzle. We are going to be focusing on looking at the graphs. What we are going to be given is functions. They want us to find domain, range, x and y intercepts, as well as maybe some other information. Let's take a look. So we've talked about what domain is. Domain is the input. Those are your x values. When we look at a graph, x values are always located on your horizontal axis. The range is the y values, and the range is going to be your vertical axis. We are going to write the domain and range in interval notation. You may remember that from working with inequalities, greater than and less than. It's going to be the same type of thing. So it's important to know how to translate the domain and range into interval notation. You want to make sure that certain values, if necessary, they get the brackets, other values get the parentheses. So if we look at what we have here on the PowerPoint, domain, we want to follow the graph from the left to the right. Why left to right? Well, it's very, very important when you look at a graph, you always have to follow it in the same manner. So we're going to treat it kind of like a number line. The left is negative infinity, the right is positive infinity. You always want to get your values in interval notation. They always need to go smallest to largest. That's going to be true for domain or for the range. Okay, so we're going to look from left to right so that we always have that flow going from the smallest to the largest. Range, we want to follow the graph from the bottom to the top. Well, the reason for that is your y-axis is vertical. The smallest y values are at the bottom. The largest y values are at the top. That's why we always want to go in that direction when we talk about the range. Interval notation, included values, meaning closed circles, filled in dots on the lines, they all get brackets. Those are all included in the graph. Anything that's excluded, open circles, positive and negative infinity, you would always use parentheses. Infinity is not a number, that's why it's excluded. It just lets us know that the graph goes on forever. So let's see what else we have. Intercepts. Intercepts, they're also going to be called zeros. That's another common name for them. They are always located on the x-axis, and you would see them in the form of x and 0. For x-intercept, the y value is always 0. That's a given, that's by definition, okay? Likewise, for the y-intercept, your x is always 0. So when you see the intercepts written as points, that's why you will always see the y value of 0 for the x-intercept and the x value is 0 for the y. So if you aren't given a graph, you can always determine intercepts based off of a function, and that's something that we will do in this course. Not today, but it will happen. It's coming along soon. Okay, so let's just look. If I have a line, I'm just going to draw a basic line. And I'm going to do it in red. Okay. I'm going to have, if I can match this up, and have that be a closed dot. And that's not very beautiful. And then this is going to be an open dot. I'm going to kind of exaggerate that so you can tell that it's open. Now, to go through domain and range and intercepts and all of that. Now, first for the x-intercept. X-intercept is always located on the x-axis. That is always your horizontal axis. So on this particular graph, that is going to be my x-intercept. How would I say that? Well, to write out my answer, if I simply say the x-intercept equals, we might have to estimate that. I'll estimate that at -1/2. Fractions over decimals, I always say. So if it allows you to give your answer in decimal form, that's fine. I prefer fractions, just a little bit, more exact. So we can say x-intercept equals -1/2, or we can write that as -1/2 and 0. That would be the ordered pair. -1/2 goes with 0. It's on the x-axis. That's your x-intercept. If I'm looking at the y-intercept, we're going to do the same thing. Y-intercept is going to be right here. So we would say that the y-intercept is +1, or as an ordered pair, I would have the point 0, 1. Okay. So if I'm telling you it's the x-intercept, you don't always need to write it as an ordered pair. There may be sometimes in the homework that you get certain instructions, they want it written as an ordered pair, and sometimes they don't care. So make sure you read the instructions carefully, whether it's in the homework or on a test or something like that. All right. So just a quick go through the domain. Now, when we talk about domain, we said we're always going from the left to the right, and that's very important with the domain. You're going to go in that direction. In this particular case here, I'm going to look for the smallest x value that's being used. Right here, this is the leftmost point of the function. So the smallest x value that's being used coordinates to -3. Because that is a closed dot, I would have a bracket here. I like to section off the axis when I'm talking about domain and range. I think that helps when you're trying to identify what the domain and or the range is. It also helps you to remember if you're using the x values or the y values. So if I start there, -3 is my point. Then I follow the graph. You can always follow with your pencil, kind of draw on it if that helps you out. You're going to the right, and then you end. Well, what is the rightmost or the largest x value that I have? That corresponds to +2. +2, though, has an open circle. So that's when I'm going to use a parenthesis. So there's a difference, parenthesis and bracket. You want to make sure that you get it right. So domain here, I have -3 to +2. -3 was included, +2 was not, so I'm going to use a parenthesis there. So if we do the same thing with the range, I'm going to go from the bottom of the graph to the top. So the bottom of the graph, the smallest y value is at that point again. That corresponds to -4. That is a closed circle, so I'm going to put a bracket. Now it is going to be sideways, and I understand you think that, well, that might be confusing. Turn your graph on the side. Instead of looking at it this way, turn it and look at it this way. And that might help you out a little bit. -4, going to the top of the graph again. That happens to be up here at +4. Once again, it is an open circle, so I'm going to use a parenthesis. My range is going to go bracket, -4, +4, parenthesis. I'm giving an interval from where I'm starting to where I end. That's the way it goes for domain and range, always. So let's do some more graphs. Let's practice with these. Each of these, we're going to find the domain, we're going to find the range, and we're going to find the intercepts. Now, with these graphs, the way they look and the way they're given, sometimes they don't have arrows. I always assume that if there's no point at the end of the graph and it's just going off the paper, I assume it to have an arrow. If they want me to know that it's going to stop, they're going to show specifically that it stops by putting a point, whether it's a closed dot or an open circle. Either one of those are going to have those to let you know that the graph ends. Otherwise, you can assume that it is infinite and it goes on forever. In this particular graph, happens to be a square root function. We're given our graph. We want to find the domain, the range, and the intercepts. Now, here we have the graph has a point. As you can see, it starts on the left. And on the right, it doesn't really do. It just looks like it's going off the side of the paper. When that happens, I want you to just imagine that there's an arrow. If the graph is going to end, if it's going to stop, it's going to have a point of some sort, whether it's an open circle or a closed circle. They're going to specifically let you know that the graph is going to end. Otherwise, if it's just going off, you just assume that you have an arrows and that it's going infinitely in that direction. So let's first look at the domain. We do have that point. We want to identify the smallest x value. Well, at that point, the x value that's there happens to be 0. Okay, so I'm going to start my domain. Because it is a closed circle, it's going to have a bracket, and we go 0, and then we have to determine where the graph is going off to. As you can see, the graph is going off to the right, and it's going to keep going that direction, so it could keep going forever. When that happens, you have to imagine what the graph is doing infinitely. When that happens, we would say that the graph is going to continue going off to infinity. Okay, that's our little sideways 8 looking thing. So my domain is going to be 0 to infinity. I'm going to have a parenthesis because infinity always gets parentheses. So it starts at 0, 0's included, the graph goes infinitely to the right, it doesn't end, and that's why we have 0 to infinity. Now we want to come up with the range. The range, we're going from the bottom of the graph to the top. So here we look at the point, the bottommost y value is here at -1. Once again, you have that closed circled, so that is included. So our range is going to start at -1, and it's going to have a bracket. Now we have to figure out where is the graph going. We're going to the top. As you can see, the graph is steadily climbing, and it's climbing, 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 and so it's going to continuously get higher as well as go to the right. Okay, so as it keeps going up, it's going to gradually increase in the y values. And so because of that, our range is going to go up to infinity. It's just going to be at a much slower pace, but it is going to keep going up to positive infinity as it keeps getting higher. Okay, so that's something to remember. The direction of the arrows, I want you to realize, is more of an indicator of the range than it is the domain in some instances. So because the arrow is going out, it's also going up. So it is telling us that the domain is going to continuously go to positive infinity, but the range, because it's getting higher, is also going to be going to positive infinity also. The x and y are getting larger continuously. Now let's talk about the intercepts. So we want to identify where the graph touches and or crosses the x and y axis. So for our x-intercept, where does the graph touch or cross the x-axis? Well, that's going to be right here at this point. So my x-intercept is going to be +1, which, remember, we said that we could always write it as the point 1, 0. It's very important that you can translate seeing a point 1, 0 into understanding that it's the x-intercept and vice versa. You know, you don't always have to be told that this is the x-intercept. If you see a point, you want to be able to recognize that fact as well. Now, y-intercept. Well, where does the graph touch or cross the y-axis? It's going to be at this point, right there, -1. So our y-intercept is -1, and we will write the point as 0, -1, depending on how it's asked. Okay, and so those are your domain, your range, and your intercepts. So let's try another one. What I want you to do, if you want, stop, pause the lesson, try this on your own, and then come back and see if you got your answers right. This particular function, this is known as an absolute value function. If I keep throwing the names of these functions out at you, don't get nervous like you're necessarily supposed to know what it is, but there will come a time when you're going to know certain shapes of graphs. You're going to need to know the names. So, you know, I'm just trying to slowly introduce those to you. So our absolute value function, I'm going to add our little arrows here. So as you can see, this graph is going to be infinite. With this particular graph, this graph has arrows on both sides. The graph is also solid. What I mean by solid is that there's no open circles in the graph, there's no holes, there's no breaks, there's no gaps, however you want to look at it. I could draw from the left side of the graph. I could use my pen to draw this and continuously go all the way to the other side. I would have one graph. Anytime you have arrows on both ends of the graph and you have a nice solid graph, it doesn't have to be a line, it can be whatever, we say that the domain is all reals. That implies that the domain is negative infinity to positive infinity. Okay, so it's very important that you can look at this graph and know that it's solid all the way through and that you have arrows on both ends. That tells you that it's infinite. If you have open or closed circles on the ends, it's not infinite. Even if it's solid, it's going to start somewhere and end somewhere. But because of the arrows, it implies that it's infinite. And so as long as it's solid all the way through, then you have no breaks in the domain. It's going to continuously go from negative infinity to positive infinity. Now let's look at the range. I like to draw on my graphs, I guess. Put my little arrow. Now with the range, we're going from the bottom of the graph to the top. As you can see, both ends of the graph, the arrows, they're pointing downward. That means that this graph is going to continuously go down, 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 down on both sides. So the graph is going to negative infinity. Okay, so we're going from negative infinity. Now we have to determine what is the highest y value, the largest y value that this graph gets to. And this particular graph, the top of it is at this point. And that y value is positive 3. So my range is going to start from negative infinity, and it's going to go all the way up to positive 3. That does have a bracket. As long as there's no open circle, we will assume that it's closed, and we will use a bracket for that value. Now we want to come up with our intercepts. So we're going to look and see where the graph touches or crosses the x and y axis. So if I start with the x, here the graph crosses at positive 5 as well as negative 1. That means that we have two x-intercepts. When I write those, I will simply list them with a comma. So I have negative 1 and 5. If I wrote those as a point, they are two separate points because they are two separate points on the graph. They're each count as one intercept. So be careful. Don't try to put negative 1 and 5 together in parentheses. If you want to enclose them somehow, you can use the braces, the squiggly lines. That represents a set. That means negative 1 and positive 5 are the set of intercepts that you have for that graph. You don't have to use the braces, just saying if you feel the need to enclose them in something. Now if we look at the y-intercept, where does the graph touch across the y-axis? Right there at positive 1. And so that will be the point 0, 1. And that's what we have. All right. Hopefully the more graphs that you work with, the easier it gets. Sometimes you might think, oh, I have it, and then you get a slightly different looking graph that you haven't seen before, and it might be a little confusing at first. But it's important to just practice with the domain and the range, writing things in interval notations, picking out your points. All these things are very important. You're going to be doing more of them in the next section. All right. So let's now talk about values. So we talked about evaluating functions. We had the f of x equals y. We found f of 2, and we found given the equation. So how does that translate into with a graph? Now, if they ask you to find f of 2, what you have is, in this instance, you are given the x. Your job is to find the y. Okay? They've given you the number in the parentheses, and they need you to find that y value. So that's what's missing. In this another instance, the way they could phrase the question is find the values of x for which f of x equals 2. So what you're doing here is you're actually going to find your x values. In this particular instance, you are given the output, the 2, and you have to find that missing x. So it's all about being able to take the function notation and translate it into ordered pairs and make sure that you know what you're looking for. So let's do some of these. All right, I'm just going to go back to the first graph that we had. Let's say we want to find f of 4. Okay, so they ask you to find f of 4. Remember, if you think about the f of x equals y, that means what you have is that your x is equal to 4, and your job is to find the corresponding y value. So what I'm going to do is go to my graph. I'm going to look and determine where x is 4. I'm going to go up to where I hit my graph, and that's my point. Well, if x is 4, what is the corresponding y value for that? You go over and you see that it happens to be 1. So 1 is going to be the answer. Okay, if 4, 1 is the point on the graph, and you're given the value of 4, 1 is the answer in that particular case. Now, if we want to find the value or values of x for which f of x equals what I want to use, we'll go with 0. Okay, well, in this case, same thing, we have f of x equals y. So they've given me the y value of 0. So where is y 0? Well, the y is always going to be 0 on the x-axis. So I'm looking to see where the graph crosses the x-axis, and that happens to be that point right there. Well, what is the corresponding x value? That corresponding x value is 1. So I would say x equals 1, and that is my answer. Okay. So in one case you're looking for your x, the other case you're looking for your y. You need to make sure that you know which one you're doing. All right. Let's do another example. Here's our absolute value function. I'm going to put some up here. Remember, you can always pause this and try these before you come back to get your answers. So let's find f of 1. And then I also want you to find f of -3. Then I'm going to have you find the value or values of x for which f of x equals 1. All right, so let's see what we have. If we want to find f of 1, let's go to our graph. So remember, we're always comparing it to f of x equals y. So in the first case, we're given the x values. So where x is 1, that's right here. The point on the graph that matches up to that, that corresponds to a y value of 2. So in the case of f of 1, my answer is 2. That's what we're looking at. Finding f of -3. Well, we go x equals -3, go down to where you hit your graph, and you're going to determine what y value corresponds to that. And that happens to be -2. So -2 is our answer for f of -3. All right, so let me clear this out. Clean up some space. Now we want to find the value or values of x for which f of x equals 1. So in this case, they've given us the y value of 1. And they want us to find the x value or values that corresponds to that. So I'm going to my y-axis, and there's y equals 1. What I'm doing is I'm going to mark off all of the points where y equals 1. That actually occurs right here on our y-axis. It also occurs over here at this point. So those x values that correspond to those points are going to be part of my answer. Well, on the y-axis, this point right here is our y-intercept. Well, what x value is that? Well, that's going to be x value of 0. Then we go to the second point over here, and y is 1. What is the x value that corresponds to that? That's going to be +4. So x equals 0 and 4, those are our answers for this. Both of those x values have y value of 1. So these 2 points, these 2 coordinates, those are the answer to that part of our question. Well, that's it for 1.2. I think we've covered enough. We've covered a lot for sure. So take all this in. Please make sure you go through and practice a lot of the different graphs. Domain and range is definitely something that you need to work on. In the next section, you're going to be using interval notation some more when you do increasing, decreasing, and constant functions. You're going to be finding more points on the graph and using graphs in this manner. So it's important to get a good start on it here so that you can transfer all of that knowledge into using it in the next section. So good luck, and I'll see you later. Bye.